Today we're going to talk about exactly what an acid and a base are. And to understand this concept, you need to remember how a covalent bond works. In a covalent bond, you have two atoms that are sharing electrons with each other. And we learned that because of electronegativity, some atoms will pull on those electrons much harder than the other atom will. And so the bond between them, the electrons between them, are actually shared unequally. So what happens is that in compounds where the hydrogen is a part of that bond, hydrogen is not very electronegative, and usually what it bonds with is bonded with something much more electronegative. So the other atom will pull much harder on the electron, or both electrons in the bond, and the hydrogen doesn't get much of the bond, much of the shared electrons to orbit around it very much of the time, and so it ends up with a partial positive charge. Now, specifically in acids and bases, what we see happening is that the hydrogen is weakly bonded, and it actually has an opportunity to share electrons with something else much more easily than it can in the compound with which it started. So in that case, what happens is that the hydrogen pulls off, but it leaves its electron behind, and then it will go to bond with something else that's already in solution with it. So for that reason, we call an acid is a hydrogen ion donor, and a base is a hydrogen ion acceptor. Now I'm going to try to show you what that looks like. You have two equations on the sheet that I gave you on sample problems for video number 2, and I'm actually going to start with the second one of those equations first. That equation says HCl plus NH3 yields a chloride ion and an ammonium ion. So what happens is that your chlorine has 7 electrons around it, and your hydrogen donates 1 electron to the bond, and so they are sharing this pair right here. Well, as we said before, chlorine is very electronegative, and so it wants to pull all of the electrons toward itself. So even though the hydrogen is sharing, it doesn't get these shared electrons very much of the time. On the other hand, if it looks over here at this NH3, the NH3 looks like this. It has a shared electron pair with each one of the hydrogens, and it has a lone pair up here by itself, and this hydrogen says to itself, if it could talk, you know what? There's a lone pair over here. I could kind of just detach from this arrangement and go over here and share this lone pair, and I probably get it a whole lot more of the time than I'm getting my shared electrons over here. So that's what he does. He actually detaches himself here and goes to join up with this NH3 so that he can share this lone pair over here, which is then what gives us this Cl minus over here, because the chlorine now has all 8 electrons to itself, and the NH4, or the NH3, since it had an extra pair, now shares this pair with the hydrogen, but this has, it already had a positive charge because it didn't have anything to contribute to this bond. So this whole ion has a positive charge on it. Okay, now we're going to get rid of these dot structures down here. And if you didn't draw all the dot structures, which you don't need to do to determine where the acid and the base are, I call it watch the bouncing hydrogen. Okay, so if I look here, look at these two, and then I look at what's on the other side. If I compare this and this, it's pretty easy to tell that the HCl is what donated the hydrogen, because over here the Cl is without a hydrogen. So this one is going to be the acid. The NH3 accepts the hydrogen. Here there's 3 hydrogens, here there's 4. So that means this one is the base because it has accepted a hydrogen. Okay? Now let's go up and look at this top equation. Again, watch the bouncing hydrogen, see where it ends up. I have an HNO3 here and an NO3 minus here. Okay, what happened? Well, it lost a hydrogen. Here's an H2O, here's an H3O plus. What happened? Well, it gained that hydrogen, so the hydrogen bounced from here to over here. So since this donated the hydrogen ion. This is the acid, and water is the base. Okay? Now, just because we've written it this way doesn't mean acids always come first in the equation. We tend to write the equations that way. I'm not sure why. We just tend to put the acids first, but it doesn't have to be that way. So what you'll have to do is watch to see who's lost the hydrogen and who has not lost it. Now, I also want to point out something else that the author mentions in the book. If I would take an NH3 and I would mix that with water, what would happen? Well, in that particular case, I'm going to end up with an NH4 plus and an OH minus. Okay, so where did my bouncing hydrogen go here? Well, here I have NH3, here I have NH4 plus. This accepted a hydrogen. Here I have H2O. Now I just have an OH minus, so this has lost a hydrogen. So here, this donated the hydrogen, so it is the acid. Here, this accepted the hydrogen, so it is the base. And so again here, I didn't write the acid first. I kind of did that on purpose, just so so you were to stay on your toes. But what I want you to notice is this. In this equation up here, water acted as a base. In this equation down here, water acted as an acid. And you have some chemicals that can act either way, and water is a prime example of this. There are others, but water is probably the best example of it. And so water is called an amphoteric substance, if I could spell that correctly, amphoteric. Some books will use the words amphiprotic. It means the same thing, but we'll try to use the word amphoteric. So amphoteric means you have a substance that can act either as an acid or a base, and it completely depends on what you put it with. If you put it with something that is a much stronger hydrogen ion donor, it will act as a base. If you put it with something that prefers to accept a hydrogen ion, then it will act as an acid. It can go either direction. Okay, so today you're going to be practicing determining whether the things in your, some of these equations are going to be either acids or whether they're going to be bases.